This is a short qualitative lecture that describes another basic aspect associated with mechanical waves, what is called reflection. Reflection is best described by asking and answering the following question. What happens when a wave encounters a boundary? For example, if a spring is attached to something, I'm going to be using a spring attached to a rigid post in just a few minutes to demonstrate this. Or what happens if you say have two springs that are hooked together, so you have a boundary between two different elastic media. Well, the energy itself can't disappear because the energy associated with an incident wave pulse, if it disappeared, that would imply that the energy was destroyed and it would violate conservation of energy. Therefore, at least some of the energy must reflect at the boundary and propagate in the opposite direction of the original incident wave pulse. This is once again known as reflection. There are two types of reflection. There is reflection at a closed end and then secondly at an open end. In a closed end situation, the boundary itself is basically locked in place. It's fixed in place, it cannot move. However, secondly, if the boundary can move, this is then therefore referred to as an open end. So let me describe both of these types of reflection to you, and I'll demonstrate both by using some springs. Okay, so first of all, we have what is called reflection at a closed end. So right here is an incident wave pulse propagating to the right, and then right here is the boundary, a closed end, and it cannot move. It's fixed in place. Okay, we depict it, as I've done here, by using a solid circle. Okay, and then right here is our incident wave pulse propagating to the right-hand side. And then think of this as the post that I'm going to use in my demonstration in just a few moments, or it's like somebody's hand holding onto the spring and their hand is nailed in place. What happens when the energy associated with this incident wave pulse encounters this closed end? Well, the energy associated with this section of the spring is going to exert a force upwards on my diagram like so upon the boundary. So if you think of it in terms of a person's hand holding down the spring, there's a force exerted on the person's hand in that direction. There's a force exerted upon the boundary. Force upon the boundary. Okay, think of this as the action in the context of Newton's third law. So then therefore the boundary, the person's hand if you will, pushes back in the opposite direction. I'll represent that here as a different color. So right here is the reaction. The person's hand, the boundary if you will, pushes back. This then results in a reflected wave pulse that is pi radians, or 180 degrees out of phase with respect to the incident pulse. And this reflected pulse propagates to the left. So then therefore we say, like so, as this propagates now to the left, this reflected pulse is inverted. Okay, now demonstrating this is quite easy to do, so let me do so. I'm going to have to move my phone so we can see this. I have a spring laid out on the floor here of my classroom. So let me go ahead and carefully reposition the phone, so bear with me here as I do. I'm going to tilt the phone downwards too. There we go. Okay, now watch what happens when I stretch out the spring and then I create an incident wave pulse like so. Notice that the reflection is pi radians or 180 degrees out of phase with respect to the incident. So that's reflection at a closed end. Okay, let me move the phone back. Bear with me as I do. Okay, let me tilt it upwards a little bit. Okay. Okay, now secondly, we have reflection at what is called an open end. With an open end, the open end is free to move. So here's reflection at an open end. The boundary is free to move. Okay, once again, just think of it in terms of forces. So let's say that right here is the incident pulse propagating to the right, and then right here is the open end, which we depict as an open circle. So our incident pulse is propagating to the right. And And then once again, if you think of it in terms of forces, we have the following. The energy associated with this section of the spring is going to exert a force upwards upon the end in this direction. So then therefore, a moment later, the situation is going to look like this. Like so, because remember that the open end is free to move. And then take a look at this. The energy associated with this section of the spring right here, when it reaches the open end, is going to exert a force downwards on my diagram like so. In other words, this is analogous to somebody just taking their hand here on the right-hand side of my diagram, moving it upwards and then moving it downwards once again. So then therefore you end up with a reflected pulse that has the same orientation with respect to the incident, and the reflected pulse propagates to the left. So then therefore the reflection looks like this. So we say that the reflection is upright and has the same orientation as the incident pulse. Now this is difficult to demonstrate by using these springs because there is so much friction associated with the floor, for example. There's friction associated with the desk if I was going to take the spring and slide it sideways on the desk. So then therefore, here's how I tend to demonstrate this in class. This is not the greatest demonstration in the world, but it does suffice. Okay, what I'm going to do is I'm going to take the open end of the spring. I'm going to set an incident wave pulse down in this direction like so. And then when the energy reaches the open end, you will see the open end rise up off the desk a little bit and then come back down. And then if you look carefully, we might be able to see a little ripple that then propagates back in this direction. That is then therefore the reflection. Now this doesn't work very well, quite frankly. Most of the time the spring just kind of flops over. But let's see if I can get something that's relatively decent. That's not too bad. You can see a reflection move back towards me like so. Propagate back, that is towards me. Okay, that wasn't very good. Let me try again. Not bad. Like so. So, no, it's not the greatest demonstration in the world, but it is a depiction of reflection and an open end. Okay?